All right, welcome to lab 7. This one is a pointer lab. So I've got two parts to it. So let's see here. So starter code looks like this, these files. Look at all of them. And there are two parts in total. So the first part is like this. I want you to do this rotate 3 program. It's got a library and a testing file. So let's look at all those right now. So rotate3.h is the header file. Can't mess with that, but here's the function that you'll be making in your rotate 3 library. All right, it's a function that takes 3 int pointers and messes with the ints that they're pointing to. All right, you'll implement it in the corresponding .cpp file. So here's how you'll implement it, and here's a hint for how it needs to be done. Your job, if somebody asks you to, somebody calls rotate 3, they're giving you 3 pointers to numbers. And what I want you to do, what I mean by rotate, is move the numbers to the right. All right, so let's say that here's some memory. X, Y, and Z is like mains memory. If you call rotate 3 on the addresses of X, Y, and Z, so give pointers to them, your rotate 3 function should, based on that, it should turn them in like this. It should rotate them to the right. So what was in X becomes in Y. So the green state of memory should happen next. So the 1 goes into there, the old X becomes the Y, the old Y turns into the Z, and then the old Z kind of wraps back around and becomes the X. So 1, 2, 3 becomes 3, 1, 2. Does that make sense? That's what I mean by rotate those 3 numbers in that way. It's kind of like swapping. It'll be very similar to swapping. It's just a little bit more general. So that's the function I want you to write. There is one caveat. If any of those numbers, if you're given normal numbers, like 42, 43, 44, it should turn into 40, y equals 42, z equals 43, x equals 44. They're moved to the right. But if any of those pointers were null, remember that's the null pointer, nullptr, you can check for that. They were the 0 address that you don't have access to. If any of those pointers were bad pointers, they were null, then your function should just do nothing at all. Don't go anywhere, don't try to swap anything. Make it all just no effect. Make it all have no effect at all. So that's what I want you to do for rotate 3. All right. So I've made you some tests in this rotate 3 test file. So the library implementation is across the header and the CPP file. Those are those. I've made you a test file with a main function. So here's what you'll compile the library with. It's got all these bad boys down here. So it's just testing that it's doing the right thing after you call it with these addresses. It turns these variables into these, messes with their values. But if any of them are null, it should not change anything. All right, that's what I'm testing you on. So that's the first part of the lab. Just get some practice with pointers. I hope that makes sense. There's that one. Remember that you can use that -G so that you can enable GDB, and that's going to help you fix some errors if you accidentally segfault. So maybe you weren't checking for null in the right spots. So that's very, very helpful, I hope. All right, so that's that one. That's the first part of your lab. And so remember to compile it with the library file. And then for the next one, I have a fun idea. Remember how I told you that secretly, when you're calling methods inside of a class, you're always getting access. There's something called this. There's something called yourself that you can access, and it's a piece of you. All right. So I'm going to have you make your own version of that. I'm going to have you make a fake counter class using pointers and this idea of having a piece of yourself, knowing where you are right now in memory, which object you're being called on. So yeah, that's what I want to do. We're going to make a fake counter class using a struct, and these methods will just be functions that are called with a pointer to yourself. All right. So secretly, deep down in code, there's a pointer called this that always tells you yourself. Gives you the address of yourself inside of every method. We're going to do it ourselves. All right. I've said self way too much, and I'm just going to keep saying it. Sorry. So we're going to make our own version of a class. All right. Kind of in the style that C++ is doing it for us, just so that we fully understand it. All right. So these are really just functions, though. All right. We're making our own version of classes using functions and a struct called counter. So we can still make counter objects. They have a count inside of them. But the constructor we'll call ourselves. It's just a function. And instead of just taking the starting value, it will take a pointer to ourselves. All right. So yeah, inside of C++, there's really something. There's a pointer to yourself called this inside of actual methods. but we're going to make our own version of classes, and so we can't use the word this. It's actually a keyword. We're not allowed to use it just like int. So we'll use self, which is what other languages use anyway. So yeah, we'll use self so that the compiler doesn't complain. And so each of our methods in quotes, right, is going to have the first parameter to the object, which is technically still correctly an object. So like you construct, give me a pointer to the object you're trying to construct and its starting value. So you don't have to think of this in terms of object-oriented programming if you don't want to. Just like you're implementing these functions. You're given a pointer to an object you want to mess with, and like this one's supposed to like go inside of this counter object and increment its count. Like it's supposed to be the inc method, okay? But it's really just a function. It's taking the place of a method. All right, it's what C++ is really doing for us whenever we're calling methods secretly. So counter reset is supposed to take the counter you want to reset, and here's the new value you want to put in it. Stuff like that. And then finally, get count it should be a const method, right? So it takes a pointer to yourself as a const pointer, and so you cannot mess with yourself. You can look at the counter's count, but you cannot change it. That's how you can that's kind of how const methods work inside of C++ secretly. Then you give back the counter inside, the count inside of your counter. So that's the header file, at least. I hope that makes a little bit of sense. Like here's what's happening. Like if inside of counter inc, somebody's giving you a pointer to a counter which has a count inside of it. It's like here's what self holds. It's a pointer to a counter with a count. Your job is to follow that pointer, get to the object, and increment the count. All right, that's secretly what C++ is doing with methods. But yeah, once you wrap your mind around that, it's really not that bad. Please read the comments. Yeah, your job is just like implement all of the functions in counter.h up in here, and that'll be that. So I've made some tests for you already. Here's kind of how you want to use them. Maybe I should have shown you this first. But like you can make a counter object, because that was just a struct. And then like you should always call the constructor first. This is what C++ is turning your stuff into secretly. Constructor with the address of that counter, and then here's the value it should hold. All right, there's that. And then like after that's true, after that's done, it should have messed with the counter, set the count. Same with these. Like you could make them on the heap. Counters on the heap is fine. Construct it, increment it 3 times. Now the count inside of the counter should be 3. Does that make sense? So like this is secretly what like a c.inc would turn into. That's what I'm trying to get across here. Okay. And then like here's a test for the reset, for get count. It's like make sure get count gives back the correct count inside of this counter. All right. Though it's being called with pointers, with the address of the counter object. Isn't that neat? I think that's fun, and that's pretty much what I wanted to tell you for like how you need to implement it for now. Get it all working, then get my tests passing. One interesting and important thing that maybe it wasn't clear when you were reading about it is this equals 0 here. This is called a default parameter. All right. This is like you're able to give something for the starting value, or if you omit it, it will take the default of 0. That's what that means. So you could have not given a second argument when calling this function. That's possible. But one interesting fact, one thing that you're going to have to worry about when you're implementing this, you can't just copy and paste and like give this a body with the equals 0 still there. You have to get rid of, when you implement it, you have to get rid of this equals 0. All right, you can only have the default parameter one place, and we're already using it here. Right, so in your implementation, you have to remove that equals 0. Like, because we've already said it once. Otherwise, it's like you're saying the same thing twice. You could have said it differently. That gets confusing. So the compiler enforces the fact that you said equals something only one place. All right, so get rid of that in the implementation. So yeah, just get the tests to pass. You'll compile it with the library, right? -j, just in case you have some weird seg faults. You can run those in GDB. And then, yeah, you'll run it and get my tests to pass. I've given you all these. And then I'd like you to add 2 more of your own tests. So test some weird combination of things. Maybe make 2 counters if you want. I don't know. Call like inc a bunch of times. Call reset. Call inc some more. Make sure get count like doesn't change its answer. Like you have options, but please in the same pattern make 2 more tests that call a search true just once more. So I've made 4 tests. So you should see passed 6 times since you'll add 2 more. All right. So I want 2 more tests, please. In any style, come up with some weird, wild, crazy idea that tests something about your counter library, some combination of stuff. So yeah, I think that's all that I wanted to say. The files that you are messing with, that you're allowed to mess with and change and turn in, will be the following. So you're implementing rotate3.cpp, so you cannot touch the header file. You're not turning that in. I'm testing with the default version. Same with the counter.h. You're only turning in counter.cpp. You cannot mess with the header file. All right, I'm using the default version. And then the test file that you're adding your tests to, of course, you're going to turn that into with the additional tests that you added. So I think that's all. Got the rubric at the bottom. Those are the 3 files that you're turning in that you are allowed to mess with. All right. So I guess you can touch. You're allowed to mess with the rotate 3 test as much as you would like, because you're not turning it in. Like, that's just for you. But you will be tested with this original version of the program though. So I think that's all that I wanted to say. So yeah, those are the files you'll turn in. And yeah, just keep watch the due date and let me know if you have any questions. That is your lab 7.